For nearly a century, the rapid development of astronomy has not only failed to alleviate human loneliness, but has instead magnified it countless times. Looking across the solar system and the entire observable universe, no traces of life or civilization have been found on any celestial body other than Earth. However, as models of solar system and planetary evolution have been refined, the scientific community has come to realize that the solar system does not contain just one Earth, and Earth is not the only place where life might have existed billions of years ago. Although Earth was a chaotic and oxygen-free planet at that time, Venus and Mars, thanks to the habitable zone and their own conditions, possessed liquid water oceans and possibly even primitive life. According to the calculations of solar radiation power, Venus and Mars, like Earth, operated within the solar system's habitable zone. This means they could receive moderate solar radiation, allowing surface water to remain in liquid form. In the first few 100 million years after their formation, Venus was a warm and moist planet. Its primitive oceans were fully capable of evolving life. But it is certain that Venus's habitability did not last long. With the outward movement of the solar system's habitable zone and the rapid increase of greenhouse gases, Venus's oceans disappeared early on. Frequent volcanic activity increased Venus's carbon dioxide concentration to 96.5%, and the thick greenhouse gases eventually locked in Venus's heat, burying everything on Venus and turning it from a habitable planet into a lifeless region with an average temperature of 464 degrees Celsius. As another neighbor of Earth, Mars was also a habitable planet in ancient times. The erosion landscapes and traces of global oceans currently left on Mars confirm this. If Venus was destroyed by the greenhouse effect, how did Mars become uninhabitable? Today, the scientific community's answer is that the sudden reduction of Mars's magnetic field made it unable to resist solar radiation. Currently, at Mars's North Pole, there is a superbasin that covers about 2/5 of the entire planet. It wasn't formed naturally, but was caused by the impact of a dwarf planet with a diameter of 2,000 kilometers about 4 billion years ago. The biggest impact of this collision event was that it destabilized the planetary dynamo effect in Mars's core region. In other words, Mars's inner core was severely affected by this impact, rendering it incapable of maintaining its original magnetic field. After the core cooled, Mars lost most of its atmosphere, lost its liquid water, and may have even lost any life or civilization it once had. However, if Mars's civilization had been advanced enough for billion years ago, they might have been able to migrate underground or to other planets. Interestingly, at the same time, Mars was hit by a dwarf planet. Primitive life was emerging on Earth. Whether there is any connection between these two events is still unknown. In any case, compared to Venus and Mars, our Earth is undoubtedly very fortunate. Over the past few billion years, the retreat of the habitable zone has supported the proliferation of blue-green algae in Earth's oceans, producing oxygen and the ozone layer. The geomagnetic field, along with the ozone layer, protected early life from solar radiation. Whether in terms of spatial position or environmental conditions, Earth has been the most advantageous planet in the solar system. But scientists are well aware that the gift of the habitable zone will not always favor Earth. In the next 1 to 2 billion years, the intensity and luminosity of solar radiation will increase, and the center of the habitable zone will gradually move from Earth's current position towards Jupiter's orbit. By then, Europa and Titan may become new paradises for life. However, in the long run, if civilization is to exist in the universe for billions or even longer years, it must find a star with a lifespan far exceeding that of the Sun. But for us today, even the nearest star, Proxima Centauri, is still too far away, and the journey to other potential Earth-like planets such as Kepler 452b and Kepler 22b is even more unimaginable. In the foreseeable future, Earth will remain the only planet on which humanity can rely for survival in the universe. No matter how many worlds there are in the universe, human civilization must continue to develop on Earth.